Hello dear students, welcome back. Today we are going to take up a new chapter, chapter number 6, Physical and Chemical Changes. In this chapter we are going to see about the different types of changes that takes place in our surrounding and how to group it in these two different categories. So the changes that are taking place in our surrounding, when we observe it carefully, in some of the changes we see that the change can be reversed back and there is no new substance that are formed. While in some cases, during the change, a new substance is formed and that substance cannot be changed back to its original form. So now, let us see how to divide, how to categorize this type of changes into physical and chemical changes. Let us first see about the physical changes. Physical changes are the type of change in which the chemical property of a substance is not changed. Only the physical property will be changed. When we say physical property, they are the properties of a particular substance which we can see, which we can feel, like that of the shape, size. So, in case of the physical change, only the physical properties will be changed, but there will be no effect on the chemical properties of the substance. This physical property, it is also known as reversible change. This is called reversible change because the physical change can be again reversed back. We will discuss about why the physical change is known as a reversible change by taking some example afterward. Let us see some more things about the physical change. This change is also known as temporary change. It is because as it is reversible, it can be again brought back, so the change is temporary. The most common example of a physical change that we see in our surrounding is the melting of ice. Ice is the solid form of water. So this ice, which is in the solid form of water, when kept in the open air or when some amount of heat is supplied to it, then at that time it will get converted into water. That is a liquid form. This is the solid form. This is the liquid form. So here, the solid form of this water, that is ice, when it is heated, it will get converted into the liquid form. So here, the liquid form of the water, when we cool it down, at the time, we can change it back into the solid form, that is the ice. So in this case, the change is reversed and there is no new substance formed. Here in this change, the chemical property of the substance is not affected. It is because the ice as well as the water, both the molecule of it contains 2 atoms of hydrogen and 1 atom of oxygen. So the formula of ice as well as water is H2O. So as there is no change in the chemical property and there is no formation of a new substance, we say that the conversion of ice to water and water back again to ice is a physical change. Now let us take up one more example. The next example is also a common process that we see in our day-to-day life. So in this process of boiling of water, if we take some amount of water in a container and apply heat energy, at that time the water will start boiling and it will get converted into steam, which is the gaseous form of water. So here, the water which is in the liquid form is converted to the gaseous form. But when this steam, which is in the gaseous form, is cooled down, it will change back to the liquid form of the water again. So in this case also, the change is reversible. That means the liquid form of the water, it is converted into the gaseous form of the water, and again, the gaseous form of the water is converted back again to the liquid form of the water. So because of this reason, it is a reversible change, and as it is a reversible change, it is a physical change. Again, in both the liquid form of the water and the gaseous form of the water, the chemical properties are the same. That is, both the liquid form and the gaseous form of the water, they are made up of 2 atoms of hydrogen and 1 atom of oxygen. So, the chemical formula of the liquid form of the water and the gaseous form of the water is H2O. So, these are the things related to the physical change. Now, let's come to the next type of change. The next type of change is known as the chemical change. Chemical changes are a type of change in which the chemical property of a substance also changes. In such type of chains, new substances are formed. So now let us see something about these chemical chains. The chemical chains are also known as irreversible chains. It is because when a substance changes to another substance, the new substance will not be able to get converted back to its original form. Because of this reason, chemical chains are known as irreversible chains. So as it is not reversible, such type of chains is also known as permanent chains. During these chains, there will be formation of new substance. In some of the chemical chains, we will be able to observe that the state of the substance means whether solid, liquid or gas. So that state of the substance will also change. Again, some other property of chemical chains are that there may be evolution of gas. Then there may be absorption or evolution of heat energy. So these are some of the properties of a chemical chains. Now let us discuss these chemical chains by taking some examples so that we will get a clear idea of this type of chains. So let's see the examples. One of the most common examples of chemical chains that takes place in our surrounding is the rusting of iron. Iron, it is a grayish colored substance. When it is mixed with the oxygen in the presence of water vapor, at that time it will form another compound known as iron oxide. This iron oxide is reddish in color. The property of the iron and that of the iron oxide, they are entirely different. The iron have a formula Fe, while that of the iron oxide, in this case, it have a formula Fe2O3. So here, when we observe the formula of these two substances, that is the chemical composition. So the chemical composition changes from Fe to Fe2O3. So here, as the chemical composition changes, the chemical property of this substance will also change. So in this example, rusting of iron, as there is a change in the chemical properties of the substance, we said that this change is a chemical change. The representation of the chemical change in this manner, we call it as a chemical equation. While writing a chemical equation, we divide the equation in two different parts by the help of an arrow. The substances that are written on the left side of this arrow, they are known as the reactants. While the substance that is formed on the other side or that is written on the right side of this arrow, we call it as a products. This chemical equation can be represented in different ways. If we represent the substances that are used in this reaction and the one that is formed in the product or during that reaction, if it is represented by the help of the word, then we call such type of equation as word equation. But if we represent the same chemical reaction by using the formula of the respective substances, then we call such type of reaction as formula chemical equation. So let us see the formula chemical equation of this reaction. Iron, it will be represented by its formula, that is Fe. Oxygen, that will be represented by O2, which is the formula of oxygen. Then water will be represented by the help of H2O, which is its formula. While that of the iron oxide, it is Fe2O3. So if we represent these substances by the help of formula of the respective substance, then such type of equation we call it as the formula chemical equation. In this formula chemical equation that we have written here, the number of atoms of different elements, they are not equal in the reactant and the product side. This is needed to be made equal. So it will be done during the balancing of the chemical equation, which we will study in the later class, in the higher class. So for now, we are not going to study about the balancing of the chemical equation. Now let us take up another example to understand better about this chemical change. The next example is burning of magnesium. Magnesium is a metal. When we apply some amount of heat energy to this magnesium, it starts reacting with the atmospheric oxygen and starts burning. During this burning process, a bright white flame as well as heat energy is produced. Now, let us try to represent the formula chemical equation of the burning of this magnesium. Magnesium, the formula of it is Mg, capital letter M, small letter z. When some amount of heat energy is supplied to this magnesium, it will react with the oxygen present in the atmosphere. Then, it will form a compound which is known as magnesium oxide. In this reaction, the chemical composition of the substances changes. Magnesium, the chemical composition is Mg, that is, only the magnesium atoms are present. But when it reacts with oxygen, it will get converted into magnesium oxide, which chemical composition is magnesium oxide, MgO. This magnesium oxide cannot be changed back to magnesium again. So, this reaction is both a permanent change as well as an irreversible change. Because of this reason, we consider the burning of magnesium as a chemical change. Now, let us take out one more example. The next example that we are going to discuss is the reaction of iron and copper sulfate. Iron is an element, a metal, which is very common, which is very familiar with us. And copper sulfate is a chemical compound which has a blue color and it looks like the sugar that we use in the kitchen. So now let us see the changes that takes place when iron reacts with the copper sulfate. When iron is reacted with copper sulfate, it forms iron sulfate and copper. Let us try to represent this in the form of formula chemical equation. Iron, the formula is Fe. Copper sulfate, the formula is CuSO4. The formula of iron sulfate is FeSO4. And that of the copper is Cu. In this change, a new substance is formed. Here, this reaction cannot be reversed back. Above that, it is a permanent change. And let us see some other changes that takes place during this reaction. Iron is a silvery grey color substance. Copper sulfate is blue in color. But after performing this change, after forming iron sulfate and then of the copper, the color of that material changes. Here, the iron sulfate that is formed here, it is green in color. While that of the copper that is formed here, it is brownish color. So here, the changes that takes place during this reaction, they are the formation of new substance, it is irreversible, it is a permanent change, and above that, there is a change in the color of the substances. So these are the things related to the reaction of this iron and copper sulfate. Now let us take up one example of a change in which both chemical as well as the physical change takes place. The process in which both physical and chemical change takes place that we are going to discuss now is the burning of candle. When a candle is lighted, at that time, the wax which is in the solid form melts down and it gets converted into the liquid form. Here, the conversion of the solid form of this wax to the liquid form of the wax, this is a physical change, because the liquid form of the wax, when it cools down, it will get converted into the solid form of the wax. Here, there is no new substance formed. The wax remains as wax itself. So this is about the physical change that takes place during the burning of the candle. Now let us see the chemical change that takes place during the burning of the candle. The chemical changes are, when we light up this candle, some of the wax will get burned out and it will get converted into carbon dioxide. This carbon dioxide is a gaseous substance which will get mixed with the atmospheric air. It will not be able to get converted back into wax again. So the burning of the wax forming carbon dioxide is the first chemical change that takes place during the burning of the candle. Now, the second chemical change that takes place is the burning of the wick. Wick actually is the thread that is used in the candle. So this wick, when it burns, it used to get converted into ash. This ash cannot be converted back again into this wick. So here a permanent irreversible change takes place. Because of that, this conversion of the wick into ash, we can consider it as a chemical change. So it is not that in the nature, when a change is occurring, only the physical or the chemical change will take place. In some cases, in some of the changes, both the physical and the chemical change takes place together, as in the burning of the candle. So this is about the burning of the candle. Now, let us come to the rusting of the iron once again, and let us discuss in details what happens during the rusting of iron and what are the necessary conditions to perform this reaction. Rusting of iron is a very common phenomenon that occurs in our surrounding. During this process, iron reacts with the oxygen present in the atmosphere in the presence of water vapor. So, two necessary conditions for performing rusting of iron is the presence of oxygen and the presence of water. This water can be in any form. It can be in the form of ice, it can be in the form of liquid water, or it can be in the form of a steam, which is the gaseous form of water. So when these two substances are present together at the time, the rusting process will occur. If one of these substances is not present, then the process of rusting will not take place. Let us say suppose there is a presence of oxygen, but there is no presence of water. At that time, even if there is presence of oxygen also, the iron will not get rusted. If we remove out oxygen and only water is present along with the iron, at that time also the rusting process will not take place. So, in order to perform this rusting process, or for the iron to get rusted, the presence of oxygen and the water at the same time is very necessary. If we compare the rate of rusting or the process of rusting in the area far away from sea or water bodies and near to the water bodies or near to the sea, that is the coastal region, we will observe that the rusting process is faster near the coastal region or near to a water bodies. Why? It is because the water vapor, the amount of water vapor present in the atmosphere is more in case of the area which is near to a water body or near to the sea. As there is presence of more amount of water vapor in the atmosphere, the rusting process takes place faster. But in case of the area which is far away from the water bodies or which is far away from the coastal area, the atmosphere doesn't contain much amount of water vapor. Due to that reason, the rusting process takes place slower. So this is about the rusting of iron. Now, let us come to the last topic of this chapter, crystallization. Crystallization. It is the process of obtaining pure crystal from its impure crystal. Sometimes the substances which are present in the form of a crystal, like that of the salt, sugar, they get mixed up with impurities. So this process of crystallization is utilized in order to remove out those impurities from that substance and obtain the pure form of that crystal. Let us see how this crystallization process takes place. For performing the process of crystallization, we are going to take the crystal and mix with the water to form a solution. The substances that are present in the form of a crystal, they are soluble in water. So, in this water, we are going to put the particular substance which we are thinking of purifying it. In this, after mixing, after putting that substance, we are going to stir it properly so that all the crystals get dissolved in this water. After that, we are going to continuously add this crystal and stir it properly. After some time, we will get a stage in which no more crystal can dissolve in this water. That stage we call it as a saturated stage. After obtaining this saturated stage, we are going to heat this solution. In class 6, we have learned that the rate of solubility increases when the temperature increases. So in order to increase the solubility of this water or this solution, we are heating this solution. So when we heat this solution, at that time, the undissolved crystal will slowly get dissolved. Then again, we are going to put more salt or that crystal. During that time, again, we will get another stage in which no more crystal can be dissolved. That stage we call it as the highly saturated stage. After getting this highly saturated solution or the stage, we are going to filter this solution. During the process of filtration, we use a filter paper. This solution will be poured here. The undissolved crystal and the impurities which are not soluble in the water will be trapped by this filter paper. While the pure filtrate, that means the solution which contains the dissolved crystal, will be collected here. After some time, we are going to let it cool down without disturbing it. With the process of time, slowly and slowly, this liquid form of the solution will converge into the solid crystal back again. So in this way, we are able to separate out the impurities that are present in a crystal by the help of crystallization technique. So these are the things that we studied in today's class and from this chapter. In the next video class, we are going to take up the next chapter. So for today, let us wind up here, dear students. Thank you.